So hello, today we'll be talking about two things. One is a robotic simulation with the Gazebo simulator, which is part of the ROS operating system. And we'll talk about maybe some concrete project we may target. Okay, so going to share my screen, sorry, with a few slides. Okay. So this year we started to review several simulators because of their recent development in the robotic world, okay? And also they can become quite relevant. Quite relevant in the just developing robots of all sorts, including rover like we are trying to do. Okay. Okay. Sorry, having trouble to try to share the screen. Just here we go. Okay. Just can you see the slides? Okay.
Yeah.
Yeah. Thank you. Okay. So this slide, this is the concept that we behind looking into simulators for robotics developments. Okay. I think this is valid in developing robots in general. Okay. But for us, as we are completely distributed over the globe, it's even more interesting. Okay. And just quickly, it's about the fact that to make a robot, we have the software and hardware part, but we often forget that there is also the environments in which the robot is going to evolve. Okay? And so a simulator really sits very well at covering, at virtualizing the software and the hardware and the environments. Okay? So that when we are trying to develop the robot, some people can work on the hardware definitely, okay? But software is a significant endeavor. And while working on the software, the hardware may not be available, okay? And so virtualizing everything is pretty convenient. So far we have reviewed, the Unity simulation environment, okay? So from the game company called Unity, and the new NVIDIA environment from their Omniverse big project, where they have a simulator called Isaac. Okay. And today we'll review another one, which is called Gazebo, and which is the most popular. Okay. The most popular also, and the older of the three that we have reviewed so far. Okay. So there is a small subtlety though. Okay. Like Gazebo has now two variants. So on the left side, you have something called now called Classic Gazebo. Okay, it's a version 11 now, and it's going to be the last version of this this line of work. Okay, so for people familiar with the robot operating system, especially the version 1, okay, that has been the foundation of ROS. Okay, it's Gazebo Classic that is used with this project. Okay? But now with ROS 2 and new understandings, a new, let's say, new scale, okay? On the right side, you have what is called a Gazebo Ignition, okay? Which is a new version and a completely new lineage. It's a complete re-architecting of the software, okay? And this is the one we are going to talk about today, okay? The reason for that is because Gazebo Ignition has been renamed recently Gazebo. Okay, it's the default one now, and the classic one is reaching end of life, and once version 11 is going to be the last version. It won't be supported, or maybe just for security updates from now on. Okay. So I'd like to make a quick demo. Okay, and the demo will be about the same robot we have been using on other demos, so that we can maybe compare, maybe talk about it. Okay, so it's about the TotalBot 3. Okay, so what is convenient is that it's an open source project, so all components, including CAD files and so on, are available. But more than CAD files, there are also the URDF models. So URDF is the file format that is used in robotics quite often these days. Okay, so it's an XML format that defines the shape of the robot to be used in simulators. Just one thing that in the demo, so far I've been using the TotalBot 3 waffle, the one you can see in the middle and the right. Okay, so the flat one. Okay, in this one, I'm using the one on the left hand side, the burger. Okay, it's just another look, which is basically the same robot otherwise. You will see such kind of environments in the demo. Okay, so where you can see in the middle the TotalBot 3 burger. Okay, and two environments that are packaged for demonstration. Okay, so on the left it's a house, and on the right it's a default environment to navigate. Okay, so going to switch screen to show the demo. So I'm switching screen because it's I'm logging to a machine that has an NVIDIA GPU, so that it runs more smoothly. Okay? And if I don't choose the right screen, which is hard to find in the list of screens, I'm sorry, it may be relatively hard to see anything basically. Okay, so can you see a new screen shared? Okay, yes. So this is a Linux machine, okay? So because the ROS and so Gazebo ecosystem, I think by default is tested on the Ubuntu operating system. Okay, so it's just a machine like that. With an NVIDIA GPU, because we have a 3D engine in a simulator. Okay, so in Unity and Isaac, we could see that they were really leveraging the GPU. Okay, and so here it's the same machine that I've been using for the 3 simulators over the past few months. Okay, and so the thing that it's I will talk about installation in a moment, okay? But once it's installed, once installed, it works well, of course, okay? But over the past few days, installing has become easier, okay? So we'll talk about it. And so once it's installed, so sorry, it may be tiny, but it's just one command, okay? It's ROS to launch. Okay, sorry. ROS to launch and the TotalBot 3 ignition, so the Gazebo simulator new name. Okay, it's just one command to run the whole thing. Okay. Okay. So this demo, as for the other demos we have seen, opens two things. It often opens the RV's. It's the RV's visualization tool, okay, and the Gazebo simulator is on the left, okay. So we can see such kind of window, okay, when we have a 3D environment that we can visit, where we can see the different elements, okay. And so let me zoom in a little bit so that we can see the robot. It's just here. Okay. And it's configured such that there is a ROS topic, okay, called a teleop, where we can send commands to the robot so that it can move around. Okay, so you can move and go forward and backward. Okay, so there is a camera mounted on the robot. Okay, so it's an Intel RealSense. Okay, you know, the one that has been discontinued. But I haven't found the topic to get the images. Okay, I wanted to make a demo where we would be we'll have the camera's main view and to navigate like that. Okay, so I haven't found for this demo, sorry. We'll try again later, okay? But we can navigate. So without the camera view, it's not that easy. I think some people who were in our first year-end party realized that without a camera, it can be hard. Even with the camera, it can be hard, okay, to navigate like that. Okay, so trying to go across the door, okay. So the reason I'm navigating a little bit is so that we can see after here in the RVs, which is a simulator that shows now the what's called the LiDAR readings. Okay, so we can see the robot. You can hardly see, I guess, but it's the black thing here. Okay, and we can see the LiDAR readings. We can also show them here. Okay. Like we have seen with the other simulators. So need to see, yes. Okay. So here, see you can see the readings from the LiDAR. So where we can have several kind of displays that can give us information that is more or less relevant to what we're trying to do. Okay. So as you can see, the reading looks like from the top of the robot, which is to be expected because the LiDAR is mounted on top. Okay.
Just so I understand what I'm looking at here, the robot is being simulated in Gazebo, and that's like a ROS message source, and RViz is reading that information and displaying the reconstructed LiDAR map, right?
Yes.
And
yes.
so both are basically running on top of ROS. So ROS is the bottom layer of the simulation, and the simulated robot is one, and the visualization is another.
Yes. So sorry, I skipped all that because it's exactly the same settings that we had for Unity and Isaac. Okay. So we have. I will just rephrase what Venkatesh has said. Okay, it's basically it. We have the software for we have a hardware robot. Okay, which is the total bots. Okay, and we have software we want to run on this robot. But before doing that, we will run it on a simulated robot, okay, which is as much as possible the same as the real robot. Okay? And this software is written with the ROS framework, the ROS operating system. Okay? And so the advantage is that by using ROS in this context, okay, instead of saying run on this hardware, we say run on Gazebo, okay, and Gazebo takes care of representing what comes in. Okay, and so the software of the robot is written to answer to commands forward, backward, turn, and so on. Okay, and normally the real hardware interprets those commands. Okay? But here, just by running on the simulator, it's the simulator that interprets these commands. So that's where we see the robot evolving. Also, on the real hardware, we have several sensors and actuators. Okay, so the engine, the motors, okay, the LiDAR, and so on. And so the simulator can also get the information from the sensors. Okay? And so one of the sensors that is the easiest to visualize, okay, is the LiDAR, because it is a rotating laser that makes all these points, okay, that gives some understanding to the robot of its environments. Okay, and so the thing that we get this data, okay, and after this data, here we show it in two ways. The reason is because it's what I've been doing over the past demos, okay? And so it's the same data that is shown, one in the RVs tool, and another visualization of the same data in the Gazebo tool that you have on the left-hand side, okay? It's a different visualization. It's just to show that the data is available. And there is slight difference between this demo and the previous ones. That before I was showing RVs because all the controls to the robots, all the commands were sent with these from RVs. Okay, that's how these demos were working, because there was no inside the Unity and ISAC simulator, there was no way to send comments. Okay, it was requiring more software and plugins that were not available yet. Okay, so I was sending comments with RVs, but Gazebo, which is basically from the same ecosystem than RVs and ROS. Okay, they have made these already these small comments that allow to control. Okay? So strictly speaking, for this demo, we don't need the RVs representation. Okay, but I showed it just to show how it is, how it compares with other environments. Okay, so sorry, is there any question or something you would like to see on this demo before I switch back to the slides? Any other question? No? Okay. So going to switch back to the okay. So just one remark is that, as you can see, it's working fairly well. Okay. But surprisingly, you see the environment is pretty poor. Okay, there is no texture. So there is no texture because I need to add them to the project, and I haven't understood where exactly they were, basically. Okay, but here you see there is no texture. Okay, and the rendering, honestly, is quite slow. Okay, quite slow compared to Unity and ISAC we have reviewed so far. Okay, so ISAC is from the maker of the GPU, so we would expect it to run pretty well. Okay, but Unity is also rendering pretty well. Okay? So here I'm not so sure why this one doesn't render as well. Okay, it feels slow, honestly. But at the same time, it's also a pretty young version of the simulator, so I'm not sure how to interpret at this point. It's just an important remark because it feels really sluggish when using it. Okay, so back to the... Okay. So you should see my slides again. Okay. So it's a slide where you see I show on the left-hand side the same environment, but with the proper rendering of the texture. Okay. So it should be easier to navigate in this environment than the one without texture, but I didn't manage to get those textures. Okay. Just about the features, okay? Well, that's pretty interesting and pretty relevant to me especially, but also in the review we've done so far, okay? Is that, so Gazebo is a simulation environment, okay? So they, one of the reasons that they, I think the community moved from the Gazebo Classic to Ignition is to re-architect a lot of things, okay? And a lot of things become much more pluggable and extensible. Okay, so that's something pretty interesting. And compared to other simulators, it's pretty promising what is available. Okay, so for example, the physics engine have always been pluggable on Gazebo, but it seems it's much easier now. Before, I have memory of just 3 physics engine. Okay. And apparently now it's much easier to just add them. Okay, so it matters because physics engines is part of the simulation, that tries to create a realistic environment. Okay, so for example, to simulate gravity, such kind of stuff. Okay, But in simulation, we can see there are a lot of specialized physics engines, for example, for water or for particles, for fire, for space, for example, okay? And so it can spur a bit of innovation around this pluggable architecture. Another feature that is interesting is distributed simulation, okay? That means that, we can make one simulation on several computers, typically a cluster and stuff like that, okay? And so to make that easier is really interesting because we can see more and more need to larger scale simulations. So typically for self-driving cars, okay? But if we think of space scenarios more interesting for us, distributed simulation can be interesting, especially when we have multiple rovers. Okay, so we have some scenarios where we have several rovers. Where we talked about scavenging pieces from each other and so on. Okay, but if we look at different plans to go to Mars, where we have a rover, several mining rovers, and so on. It can require quite some power to simulate these situations. So distribution is really interesting. Interestingly, also there are several included models, to simulate sensors and noise. Okay, and it can be very interesting to have this capability and being able to isolate the components. Just for example, there are companies asking us here to simulate wireless network issues. Okay, because with wireless communication between a robot and some base station or something like that, it's enough, for the connection to be cut to have a lot of problems. Okay, and so simulation helps to study what can happen and what the behavior of the robot should be and so on. Okay, so to be able to simulate that is really good. There is a 3D engine, so that's the rendering you can see. Okay, so it's an open source one called Augur. Okay, apparently it can be switched to. Okay, I didn't look into that. I talked about pluggable earlier, but it's also extensible apparently. Okay, so there are quite a few things that they point out on the website. Okay? And also interestingly, that same as NVIDIA and Unity, they have an asset store. Okay, that's pretty cool. Okay, where you have a lot of environments, and I will try to show some a bit later because there are some lunar environments, some cave environments, stuff like that, in which you can simulate small rovers like the Turtlebow to see how they do. Okay. There is a big difference that we will review just after, is that Unity and Isaac, they have a much richer UI when you load them, okay? Here, I didn't point that out, but the gazebo window that you see, there is almost no action available, okay? We can't create shapes, we can't add a cube, we can't add, we can't build things directly right into the GUI, basically, okay? Everything is done in code, in some kind of XML. Apparently, mainly XML. Okay, so it's mainly from the code. Okay, so it's a very different approach from Unity and Isaac, which for Unity is understandable because they come from 3D development, 3D game development. Okay, so they have a very rich environment for that, and they try to extend to the robotics development. For Isaac, it's less clear. Okay, but they clearly take an approach that is similar to Unity. Okay? Gazebo is really bare screen, okay, that shows the result of the simulation, okay, plus offers some integrated command. So it's a pretty different approach and a pretty different feeling when you're using it. Okay? And so here, a small table, we don't need to review it, but it's in the link to this slide, okay? But we can see that there is a lot of coverage, okay? And here, it's not, I'm not trying to be comprehensive and so on, just pointing out interesting stuff for things that we've been doing, okay? Or talking about at least. Okay? And so here, the big difference is that Gazebo is the only one that is open source, completely open source, okay? Meaning that we can really do a lot of things with it and control. And from the installation, we can see a big difference. Okay, it's NVIDIA and Unity, you have to install a big thing, okay, that does a lot of things that we don't really need, okay. Here, Gazebo is broken down into a lot of small, specialized packages, okay, especially when coupled with ROS integration. ROS integration for Unity, I put a warning mark because it looks like it's hardly supported, honestly. Okay, that there were some attempts, but apparently they're not really committing to it. Interestingly, on photorealism, so on simulation, it's not always needed photorealism. Okay, but I put some ranking of my feelings so far. Okay, that YARG is really the best. Okay, second is Unity, and the Gazebo is far behind. Okay. Headless mode is something pretty cool that it's not using the GUI, okay, so that you can do simulation without all that, you know, and get results this way. Okay, that can be pretty interesting, but not all of them seem to support it. Okay, and after, most of the differences is about how extensible and pluggable the system is. Okay. So for YARG and Unity, because they're not open source, it's not super clear. Okay, there are some things we can add, but it's pretty much controlled basically. Okay, by their tooling. Okay, but for Gazebo, especially the newest one, so Ignition, they spend a lot of work on architecture to make that pluggable and extensible more easily. Okay, so a few extras based on the recent discussions, and that's basically the end of the presentation, okay? Is that we talked about the URDF, file format, you know, to specify a robot for a 3D environment for simulation, okay? So it's supported in Gazebo, but the Gazebo project has a sub-project called SDF, okay? So I think the scene definition framework, scene definition formats, okay? So you have the link here. So what's interesting with SDF, we mentioned that a few weeks ago, is that you can define the robot and the world inside it, okay, in a single format. Okay? And so it's more generic than URDF, and I will need to switch screen to show some example, but it's basically an XML file okay, that is pretty short, honestly, compared to other formats, where you can really link to the robot's body itself and the world. Okay, so pretty convenient. And you know, you can control features of the environment. So, for example, if you want a world on the lunar surface, you can change the gravity pool and stuff like that. Okay. Yeah. So it was pretty interesting in our discussions recently. And after a few notes on installation, because over the past, I've been working with Gazebo, the latest version, for a couple of weeks now, and it has changed a lot over the past few days. Okay, so if you're trying to do it yourself, it's better really to get the freshest data because it's working better and more easily. Okay, it's a one command instead of 50 commands, basically, literally that much. Okay, so I'm done with the presentation. Is there any question or something you would like me to show again?
Can you give me a feeling for what it takes to set this up on my computer? So I have a blank Windows computer, sorry.
Yes.
And I want to run the simulations that you showed us.
Okay, so on this slide, there are a few links, okay? So, so you're on Windows. So first, okay, no idea, okay? I didn't try.
Okay, fine, I'm Linux, fine, I have a Linux computer.
Okay, no, so because in the links, there are, I think it's a pane kind of automated 10 days ago, okay? Yes, so no, it's working, okay? It's a link to a repository. I don't know whether you will see it. Yes.
Mm-hmm.
You should see my screen, I think. Yes. So it's
yes,
a small repository I wrote. I call it Ignite. Okay, very creative, you know, where basically it should be a single command. Okay, kind of. Okay, assuming the requirements are on a Linux machine.
Is that
it should
all
be.
I need?
Yes.
Is that all I need? I don't need anything else. I just take a clean Macintosh with macOS 12. And
so, So,
installs
so-
it,
so what-
and that's it?
So as a marketing, I would like to say yes, that's all you need. But for me, I tested it completely on Ubuntu 22. Okay, and here it's supposed to support macOS 12. Okay, because I started on the Mac because that's my native machine. Okay, and I made some progress, but I didn't have time to get back to it. Okay, for the demo, it was. I wanted to have on Ubuntu 2, okay? So I switched to Ubuntu, okay? So the script supports macOS here, okay? So there is a whole section that we'll use for macOS, okay? And so it's, I need to get back to it to make sure that it works completely, to be honest, okay? But it supports macOS, yes. So, I need to add, because you would have a requirement to the homebrew package management, if you're familiar with that.
No.
Okay. So, tested and working on Ubuntu 22, so I guarantee that because that's
Yeah,
what you
but
saw
just
today.
I'm trying to understand. I'm saying I take a clean computer,
Yes.
I run this code, and
Yeah.
then what command do I run in order to get what you showed us? In other words, if I
Okay,
want to
so-
do a hello world process.
Okay. So that's what I was talking about here. Okay. That it's this one, sorry. Single command. Is that they've changed that over the past few days. Okay. And so is to go here. Okay, to follow this link from the slides. Okay. Because so there are some preparations, but it's basically explained. Okay.
Yeah.
Okay. Sorry, I need to be like a cat and fall back on my feet here. Is that here?
Okay, I'm not
It will-
trying to put you on the spot. I'm just trying to
Oh
understand.
no! It's just that I'm my brain is half sleeping, but not left right, but forward backward. Okay, and so the thing that here, what I show today, Ignite is just to install Gazebo to have it run locally. Okay?
Right.
But the demo requires the TurtleBot 3 extras. Okay, and so that's something that I was starting to add to this repository, but it's not finished. Okay? So eventually, okay, in a few days, it will be everything in this repository to have the demo you've seen today. Okay, and I like to try to have at least a single command to do it all. Okay.
Wow.
So eventually it will be here. Okay, but if you don't want to wait for me, it's this single command thing. Okay, so it's this plus a link to the TotalBot environment, which is also something about apt-get install kind of thing. Okay, so sorry, I'm really half sleeping apparently. Okay, that the what you saw today, I haven't written a single line of code. Okay, the only thing I've done is to collect the different data of what I wanted to show. So that is Gazebo, Gazebo Ignition, ROS2, and the TotalBot kind of tutorial. Okay, and to put them together. Okay, and so putting them together is not super trivial for a bunch of reasons. Okay, but not super complex, and I didn't write a single line of code. Okay. It was just to make them work together for the demo. Okay. Okay. So I will put that in this Ignite repository. Okay, but basically right now today it's a little bit of work to do on your own. Okay. Sorry.
I may have missed, I missed the first part of this, but what is the relationship between running Gazebo and running ROS? And do they run on the same, do you have to run in the exact same environment, or were you running like a ROS stack somewhere else and then Gazebo on one machine?
Yes. Okay, so
I remember
everything is on
ROS
the-
being difficult to install is one of the why I asked.
Yes, indeed. So you're totally right, and I think it's still relatively demanding to some extent. Okay, but it's much easier than before. Okay, on ROS 2, okay, they are making a lot of efforts to make it easier to install. Okay, across systems as well. Okay, okay. So first, everything I've tried to do the same as for past demos. So everything is on a single machine. Okay, so it's on this Linux computer with an NVIDIA GPU. Okay, so everything, the simulator, ROS, and the rest is running on a single machine. Okay. After the ROS code, the ROS system is the robot software, the robot brain. Okay, that's what we want to run on the robots, basically. Okay, that's the ROS part. Okay, and so this is where we have the ROS software itself. Okay, the framework code and our specific code, you know, to call the different motors and to get information for the different sensors and so on. Okay, and react based on that. Okay, that's the ROS part. And so this part, eventually we want to run it directly on the hardware. Okay, directly on the hardware TotalBot 3. Okay. Which is a robot you can 3D print, okay, with standard LiDAR and stuff like that, okay. But the same software can be run directly on a simulator, okay. And so here in the demonstration, it's the simulator is Gazebo, and the raw software is untouched, okay. We just run it, okay. And the only requirement for ROS is to be on some kind of Ubuntu system, okay. So the ROS system doesn't know whether it is on a real robot or not. It just knows it's Linux, and it will just start. Okay. But instead of being on the real robot, we are on a computer that has a simulator, and the simulator will plug to this ROS environment. Okay. So there is a ROS bridge, like we had for Unity and Isaac. Okay. And so basically, the simulator will claim to be the hardware robot. Okay. So did you answer your question, Rhett?
Yes. I think for your Ignite repository thing, that is installing Gazebo, but is it also installing ROS on macOS?
The repository I showed here is just doing Gazebo now. Okay. Now I will add, to make the demonstration with the TotalBot, because I'd like basically to add to this repository what we've done, what you've seen today. Okay. I just need to add installation of ROS and installation of the TotalBot 3 software, which runs on ROS. Okay, so that everything will start together. Okay.
Do I need a GPU in order for this to work?
I don't think it's a requirement, but it's highly recommended.
Oh, okay. So it'll be really slow and clunky.
Yes.
Okay,
Yes.
that's fine.
Yeah. And so
Hello world is just hello world.
Yes. Yes. And the thing that you have an environment called empty. Okay. And I think it's a pretty well chosen name. Okay. It's completely empty. Okay. So just you just have the robot and you can just navigate basically on a flat surface. Okay? And so it can be lighter. And so the thing that I need to check on macOS, because on my machine there is a GPU, but it's not an NVIDIA GPU. Okay. And so I'm not even sure that Gazebo can use it. Okay. I think it can, because it's using OpenGL, which is supported by this GPU. Okay. But I don't think it's a requirement. Okay, it's recommended, of course, but not a requirement. Sorry, to get back to Red's question, is that I'm trying to show a past presentation, the one on Unity or Isaac. Okay, that I have some graphs about the relationship between ROS. Maybe it was here. Between ROS and yes, okay. So on a single machine, Okay, there is the simulator Unity. So here it's Gazebo. There is a container. It was a container. Here it's not a container. Okay, but it was the ROS and the software for controlling the robot. So the brain basically component, and there was the browser, okay, and a connector between the simulator and the robot brain. Okay, so it's the same, exactly the same setting. Okay, just with different names. If it was not clear, sorry about that. But there is a continuity between the three sets of slides for, maybe there is not for Isaac, but for Unity and Gazebo, it's the same. To make them easier to compare, I try to have the same, okay? Would there be any other question? If not, so the slides are available, and there are several links, okay, about different things that I'm sharing, okay. And so, following the question from Meyer, what you've seen today is the repository I've shared. It's almost, it will be completely automated, okay. On Linux and Mac. On Windows, I don't have a Windows environment, sorry. Okay. Apparently, it's supported. It was not before. Okay, so that could be good news as well. Okay. But otherwise, if you have questions or trouble, because I guarantee there will be troubles. Okay, I'm starting to have some mileage to share about it. Okay.
I have a lot of questions, but I got here so late. I think I just need to go over the slides.
We can talk about it now, or we can postpone, as you prefer.
Has anybody asked more about the comparison between, because the comparison I think is particularly interesting, probably to a wider audience, not just on the call, between the options. Because yeah, these are really the options. This is it right here.
So there are some other contenders, okay, like Coppelia and Webot, okay, because they are open source as well, okay. But in terms of, I say, on noise, okay, these are the three main ones indeed. Yes, that these are the three. I'm pretty interested in Webot, honestly, for several reasons, okay, but. When talking about simulators with people, when they know simulators, they know these three ones maximum, basically.
You say noise. Did you have a more elaborate meaning, or just in terms of these are what's popular or hot?
Oh, it's just popularity. Okay.
Got it.
It's on social networks and all. I'm compiling data from all the companies we are meeting here, okay, and we met quite a few new companies thanks to the ROSCON, so the ROS conference that was where I live a few months back, okay, and so it's a ROS conference. Everyone knows Gazebo, okay, but otherwise they are talking about Isaac. Isaac is a pretty exciting. A lot of people these days. And some people talk about Unity is still also popular, okay? But surprisingly, Unity for their ROS integration, it seems there is no activity, okay? So it seems that in order, Isaac is the most exciting. Gazebo is the incumbent and pretty exciting too, thanks to the new architecture they provide, okay? The ignition approach. Okay? And Unity is just lingering, apparently, in the community.
Yeah, I feel like I've heard whispers that they're kind of moved focus away from robotics. Like I know they had a team that was actually actively working on it, but is that true? Have you also heard that Unity it's become deprioritized?
So here in Japan, I see more companies using Unity. Okay, but the thing is that it's people who have a relation more or less to game development. So it's not surprising. They are reusing a tool they know. Okay, and that makes a lot of sense. Okay, but I'm looking at signals like GitHub activity, like how much people talk about it. Okay, and the signals are really down. Okay, like for Unity, when we look at all their, you know, it looks nice because they have a kind of GitHub, you know, top page. It's called Unity Robotics. Okay, we talked about it. There are some, you can find the links in the presentation. Okay, it looks really nice. Okay, but after when we look at the, you know, the on GitHub, you can look at the activity of the repositories. Okay, and it's almost a flat line. Okay, it went down at the beginning of 2022. Okay, so it's already a year, and I don't see any reboots. Okay, so that kind of signal usually, you know, means a lot of things, especially slowing down. And so we have to put that on the background of many companies reducing their staff. Okay, so all the major companies. Okay? I don't remember numbers from the Unity company, but it looks like a systemic situation. Okay, and so robotic is not a main business review. Is not a main activity for Unity, at least at this point. Okay, so I don't have a direct feedback. Okay, but you know, all the metrics we can observe indicate that it's not a priority.
Got it. Yeah, I was mostly asking because one thing that's really hard with the Git commit timeline is just that's so often kind of the tip of the iceberg, and there's so many private commits happening. It's just lacking visibility. And so, you know, like Ross Industrial is just heavily driven by companies that were willing to actually open source some of their internal tooling. And that's something that it's like there are things happening that you just can't see. It's very opaque outside of Ross specifically, because Ross is, you know, very heavily open source. So like the progress with Isaac and all these things, I think it's a bit more opaque is a challenge. I'm curious, did you talk at all? So this is all comparing simulation environments running ROS as kind of like the brain. Did you talk about Isaac as the brain running in these simulation environments? Because there's multiple layers, and we have a link between them.
And so, no, yes, I looked at Isaac in a way that I could compare it to Unity at first and eventually to Gazebo as well. Okay, so I didn't look at it that way. Okay? I just looked at an environment to test a robot. If possible, without ROS, okay, but also with ROS. So I didn't look at it that way, and that's pretty interesting, actually. Yes. So Isaac is part of the NVIDIA Omniverse, and that's pretty interesting. Honestly, I'm still not completely sure what Omniverse is, but by studying Isaac, I found a lot of coherence in that Omniverse thing. Okay. And you know, around digital twins and so on. Okay, so a lot of keywords and so on, but it's from a robotics software development perspective, it makes a lot of sense. Okay, and we've just talked about the fact that it's you know, it's opaque what they're doing in Unity and Isaac, but I find that Isaac, at least the way they are doing it now, okay, looks pretty active. Okay, so we don't see GitHub commits. Okay, but the you know, the web page, the documentation is well written, it's up to date. So you know, there is a new ROS, and they have recently it's a ROS Humble, ROS 2 Humble, and there is a new one, ROS 2 Rolling. Okay, and the documentation gets updated. Okay, so it gives a feeling that it's active. Okay.
Yeah, I don't know. I was just curious, and
Yeah.
I mean, my take is the only signal that, you know, it's like very public is Claire Delany left 9 months ago, and Isaac was kind of her baby. So I really don't know who is going to pick it up internally at NVIDIA. As NVIDIA kind of like maybe shifts to be more of a software company now. But yeah, I think it's an open question.
Indeed. Sorry, I don't know more about it, because for me, YARG is a discovery over the past couple months. Okay. So I don't know much, and all the activity happens anyway in California. Okay. So there is an NVIDIA branch here, pretty big actually. Okay, but they don't touch that apparently. It's promising. It depends what they will do. It depends on the economic background. Okay, that may just cut. But NVIDIA, anyway, with the success of the Jetson platform in the robotics world. Okay, I don't know how much they value the business of Jetson, but it's really successful. Okay, I mean it's actually hard to buy Jetson because of the high demand. Okay. It seems that robotics matters for NVIDIA, okay, and so all the YARG attempt may survive thanks to this interest, okay. At least it's really pleasant to use, and we see a lot of effort, into making it usable, capable, and so on. Okay, it's more like it looks like a bit clone of the Unity efforts, okay, more than Gazebo. But I don't know, it's promising, but we'll see. We have to wait to see what will really happen with all that. Okay.
Do you think open source?
Sorry.
Oh, sorry. I was going to ask. Do you think open source is optional when it comes to a robotic simulation platform? How important do you think that is long term?
It depends on the perspective. For me, it's very important because I'm using simulators as first level components. Okay, because I'm trying to build and to build a product based on simulation. Okay, and so it's important so that I can configure deeply this piece of software. Okay, so change the physics engine depending on whether I'm in space or in deep water or stuff like that. Okay. And add components, add new sensors, and so on. Okay, so this is where open source is really important from my perspective. But from a generic robotics development perspective, I'm not so sure it's very important. And a big signal for me that several companies here, okay, they move away from Gazebo Classic, okay, to Unity. I don't know whether they will go back to Gazebo for Gazebo Ignition, okay, but they use in Unity because it just meets the requirements, okay, to test so far, okay. So so I don't know. However, I doubt that these companies can use Unity, the current Unity integration long run, because if it's opaque, how to make a new sensor, how to make a new, if it's difficult to make a new environment or a new robot and so on, okay, it's difficult to extend or to plug new things, new hardware, a new LiDAR, and so on, or to tune. Maybe there is a LiDAR model to simulate, okay, but there are new LiDAR hardware that come in with new specs and so on, okay. So if it's difficult to do that, several companies will have to move away from a simulator like Unity, okay. And so this is where open source can be very interesting, because we can extend, we can copy paste, we can reuse what others are doing, okay. And when it's open source, there are some enthusiasts, okay, who make, oh yes, I bought this new fancy LiDAR and I made a model for Gazebo, okay. That can happen, and that can be appealing for several professional development teams. So I'm not necessarily ultra proponent of open source, okay, but I can see a lot of advantages here because of the ecosystem, because of the evolution of hardware and things like that. We are just
think
at the
it's-
end of the hour. Oh, sorry, please.
I was just going to say, I find it very exciting that the very first thing that came up on the app, like I don't know, community installable assets for Gazebo, is the Oak D light, and it's got like everything to give you simulated camera and simulated IMU from the Oak D. It's kind of cool.
Ah, yes. Yes.
Just happened to be on the first page.
On the page for the for Gazebo Ignition, right?
This is app.gazebosim.org.
Yes. Okay.
Yeah, where all the models and stuff come from, I guess.
Sorry, where was it? So you're talking about this app, right? Here.
Yeah.
Yes. And
So you can kind of get an idea for the kind of assets that are available, which is kind of cool.
Yes. And so in the presentation, this is what I call the asset store. Okay. Just because it's called asset for the other simulators. So, but yes, what Red is talking about is this. Okay. Where we have there are a lot of cool stuff. Okay. So I mentioned about a cave world. Okay. But you can just download. I wanted to demo it today, but sorry, I didn't have time. But basically, you just download it and you can run it as it is. And where is the one you were talking about? Red?
Oh, if you go back to the front page, it's like
Sorry.
the very first thing on there. Right there.
Oh,
Oak D light.
the Oak D, yes.
Yeah.
Yeah. So the Oak D light, if is a sensor, it's a depth camera. Okay. And it got popular these days. So because part of it is because Intel has stopped their own depth camera called the RealSense. Okay, so they completely discontinued it. And Oak D is also working with the OpenCV community. Okay, and OpenCV in the computer vision is pretty strong. Okay, so got popular with that. So you can get the sensor directly into Gazebo. So it means I didn't look into it, but it means you have the 3D model, to show in the simulator, okay, to put on your robot and so on. So when you build your robot, you have an XML file and you can add this component directly. Okay? But it also means that you can have the ROS topics. That is, a ROS topic is an output from the sensor so that you can read in your ROS software. Okay? So you can get the reading from the depth camera. So sorry, we are at the end of the hour. Okay, so we spent the whole hour on Gazebo, which is probably interesting. Okay, but we didn't talk about what we could do as a group. Perhaps we could do that next week, unless there is someone presenting next week.
No, there's nobody on the calendar as far as I can see. So yeah, next week we can do the group discussion thing.
Yes. Okay.
Right.
So I think just a prerequisite, not prerequisite, but it would be nice if we, there is a thread about this topic. So if you, until next week, if you can have a look at the thread and even comment directly there, okay? That would be good, so that we are all up to date and maybe we can, how is it called? Take a decision, make a plan.
This is the yearly, hold on just a sec.
Yearly Commons. Yeah, so it's a strange name, okay? The name is based on discussions we had last year and the week before, okay? It's to have something common, okay? So it's not commons like in communist, huh? Okay?
All right, so everybody has a to-do item, review this thread, and yeah, we'll talk about it next week.
Yes.
Right.
Okay, thank you, bye-bye, and good skis for some people. Huh? Cheers.
Bye bye.